Oh, hey y'all, Billy Thomas here, and I'm sitting here in an SR-22 Cirrus aircraft. We're going to get a little creative in today's tutorial and use this aircraft to give us a 10,000 foot flyover of SQL Server.
Let's get to work. Hey, before we take off, we're going to need to do a little bit of planning. And if you take a look at the map displayed here on the screen, you'll see all the different places we're going to stop on this flyover. And we're going to start with a pre-flight check right here on Hilton Head Island. Well, our pre-flight is going to be way easier than trying to pre-flight this SR-22 sitting behind me. I'm going to need you to check three things before we get started. Number one, do you have SQL Server Development Edition installed? Number two, do you have SSMS or SQL Server Management Studio installed? And number three, do you have the Adventureworks database downloaded from Microsoft and have restored that to the SQL Server? If you have not, I'm going to leave the links to those videos that I've created to walk you step by step through that in the comments so that you can do that. And if you need to, go ahead and do that right now.
Let's get this guy started. And we're off.
Our very first flyover here is going to be on tables. And if you have successfully completed the prerequisites, you should be looking at a screen very much like mine here, where you've launched SQL Server Management Studio. You've got the Adventureworks 2022 database restored. Let's take just a second and talk about what a table is. If you really break it down, a table is nothing more than rows and columns of information that's stored together and organized in a database. Another way to look at it might be if you've used a spreadsheet and you've got a spreadsheet with those rows and columns, and each one of those worksheets, if they got moved into a database, each one of those worksheets would be a table. Let's take a look at it in SQL Server. Under databases, if you hit these little plus signs, it opens up more options. So I hit databases and there's my Adventureworks 2022. Now I can click on the plus sign there and then it gives me all the things inside of that database that we can look at. And right here, look at this. If we go right here and we look at that, it says tables. All we have to do is hit the plus sign on that and we'll see all the tables that were delivered to us in the Adventureworks database. Now, if you've created your own database, there's not going to be anything in there because you've not created any tables. So each one of these tables represent a organization of rows and columns of data. And so if we look at any one of those, and the way we look at that is we find the table we want to look at. So for example, if we want to look at this product table, we click on it, right mouse click, and it gives us a selection of different options. And I'm just going to hit this one that says select top 1,000 rows. What that will do is over here, it will bring up the SQL and the data for us to look at for that table. And if I just kind of size things up here and I look at this, I can see that there are many columns and rows of data. As a matter of fact, we can see that there's 504 rows in this particular table, and there's a bunch of columns. Now, if we wanted to understand more about this table, how could we do that? Again, if we go back over here and we click on the product table and right mouse click on that and hit design, this will tell us about how this table has been designed. And this is where things can be a little bit different than Excel in that we have a lot more flexibility with data types. And we're going to get that in our next stop. But if you look through here, each one of the columns is defined with a column name and a data type, and then whether or not we're going to allow nulls. But we can go through this design and we can see all of the columns that we're going to be able to use in this table. Now, while we're right here, let's go ahead and I want to show you just a couple other things. Let me get rid of this out of the way and close this out. So we did a right mouse click and we hit select. We can also do a right mouse click and hit edit. Now you have to be careful. In edit mode, guess what? You can change the data. Select mode, you cannot change the data. So just keep that in mind. Well, once we're in here, you can see you've got the rows and columns displaying. Now, this is where I just want to pause just for a moment and take a look at some of the features of SSMS. Up here, you have the ability to turn different panes on and off in here. So like this one, it says show diagram. So let's do that. There we go. There's your table. Over here, it says show criteria panel. And then over here, we can see the SQL pane. So we're gonna have 4 different panes open in here, and then they're all sizable. So you can go in here and move things around, scroll through the data, so on and so forth. So that's the other way that you can take a look at a table is by right mouse clicking and hitting edit. Last thing I wanna do, just to show you when it comes to a table, is you can hit this new query here in SSMS and it gives you a blank place to type in SQL. And if you just say select star from in your table name, production dot product. And we click that. Now you notice it did start bringing up an autocomplete. We can just click on it, double click on it, and it will fill it in. And then if I just hit execute, that will also bring up the contents of a table. So that's 3 ways you can use SSMS to take a look at a table. And now we're going to get back to flying and head over to data types. To get the ball rolling on data types, I want to go right back to the same table we were looking at. So I'm going to go over here to product. I'm going to right mouse click on it and I'm going to hit design. That's going to bring up the design of all the columns of this table. And if you look at this guy right here, this column in the design of the table, you're going to see all kinds of different data types. We've got integer, varchar, flags, money, date time, so on and so forth. And I actually brought up the Microsoft SQL Transact SQL data types documentation because there's way more detail that you're going to want to go into around data types than we can do in a flyover. But let me just say this about the data types. What you're doing with a data type is you're trying to keep the users, or whether you're an interface or an API, you want to keep the data in some sort of uniform manner. So in other words, we don't want an alphanumeric string in a date field, right? So if you're trying to search for dates and there's data in there that's not dates, that's what we call junk data or dirty data. That's no good, right? So with SQL Server, you can actually tell the system what data is allowed to go in that column, which can be super helpful for structuring the data for a table. Now, let's just take a look at a few of these data types. So when we see like product ID is an integer, if we right mouse click on that product and hit edit, it'll bring up that table and we can look at the product ID. Do you see in the product ID how it's just numbers, right? It's actually a whole number, right? There's no decimals, it's an integer. And if we go back and look at the data types documentation, and we go down here and take a look at where it says int, right? You'll see that an int data type, what is that? 2 billion minus 2 billion all the way up to positive. So there's about 4 billion numbers that can go into an integer. But you can also see that there's 4 different integer types. There's a big int, an int, a small int, a tiny int. And without getting into a lot of detail, what that's all about is really optimization for storage. If you look over here in this column right here, you'll see there's different storage amounts allocated for the different integer types. And so if you're an architect, you only want to use as much storage as you possibly need so to keep things optimized. And again, maybe way too much detail, but you need to understand a little bit of that. Now, let's look at another data type. So in varchar, what the heck is an in varchar? So in varchar is really alphanumeric. In other words, anything goes. Numbers, special characters, letters, whatever you want to put in there, you can put in there. And when it says varchar, that means variable character, meaning that when it goes to store it, it will store up to 50 characters long, but it won't allocate 50 characters for a 5 character text or character length of data, right? So what you're doing there is, again, it's space optimization. That's what the difference between a char versus a varchar is. And if we look at that data, so if we look at the name column over here in the name field, you'll see that, there's numbers, there's letters, there's spaces. I saw a dash in there, which is a special character. Anything goes. The same thing in this product number. Do you see how it combines a 2 letters, a special character, and numbers? And that's because it's defined as a varchar. Let's take a couple more looks here at, how about this one, a bit. Well, a bit is just exactly what you might think. It's a 1 or a 0, and another way of saying that is a true or a false. So you'll see falses and trues and nothing else in that data type. And then, without getting into a lot more detail, money is just a numeric with a couple decimal points. And then if we look at date time, that's exactly what it sounds like. You're actually storing a date character and time characters in there to help you establish. So sometimes you're trying to record how many seconds in between phone calls, or it's not just how many days. You can get down to very, very minute amounts of time. And again, I'll refer you to this in the Microsoft documentation, so that if you want to look at a special data type, or you want to get into something like understanding a little bit about date time, you can click on that, and then it'll give you all the information around that data type. So just remember, a data type is really a way to structure a database so that the right data gets into the right column. And now we're off to the query designer. This is going to be a lot of fun for you that maybe have never written any SQL. It's the closest thing to AI that we have in SQL Server. Let's take a look. Let's use SSMS to take a look at the query designer. You might have your table still open here, and if you do, you're going to want to collapse that. So find the little minus box next to tables, click that. That should collapse it down, and then you should see this folder called views. If we right mouse click on that and hit new view, it's going to bring up a dialog window that's going to ask us, what table do we want to start working with? And for this example, we're going to use the product table that we've been working with. So a little shortcut, if you hit P, it'll drop you down to all the tables that start with P, and then you can double click on product and we'll put it into the window. Now this is the query designer, and this is the closest thing to AI that we have here in SQL Server. If you take a look at this, this is going to start writing SQL for us right here. There are 4 different panes that are showing up here in the query designer. We have the diagram pane, we have the criteria pane, we have the SQL pane, and the results pane. And of course, there's no results right now because we haven't told it what we want. But this is super powerful because it actually will write the query for us. Watch this. If I hit the star right here and say I want to see all the columns, it actually puts that down into the SQL. It actually types the SQL for us. It's saying select star from product. And then if we execute that, we can see the columns and the rows. We're going to stay here and use this query designer to walk us through the next flyover, which is the select. When it comes to the select statement, I'm going to suggest that you use the query designer to help you build your skills around select. In SQL Server, you can do things, either using query designer, or you can just type out the SQL. And let me show you that. So here in the SQL designer, we've used, a graphical interface to create our SQL. If we wanted to type out the SQL, we can do that. You just go up here to the new query button, click that, and it gives you a clear pane. Now, one of the things you have to watch when you're doing queries, in this case, and I only have one database, you want to pay attention to what database you're pointing to, Adventureworks. But what I'm going to do is I'm going to type out the query and do the same thing that we did with the query designer. So select star from, it was production.product. And then if I hit F5 to execute that, it will work. All right. So That's easy enough, but we're going to start getting into, well, what if we want to just get certain columns, or we want to alias those columns, or we want to order them? How does that happen with SQL? Well, let's take a look. If we're using the query designer, the first thing I'm going to do is remove this select star, right? So select everything. And I'm going to say, let's just look at some key fields here. Let's look at the product ID, the name, the product number, and then let's go down here to the start sell date. Now, if you followed along, you can see the SQL being typed out here where it says select the column name, comma, column name. You know, each one is being typed out for us, right? Now, if we were going to do that here, we'd literally need to type them out, right? Instead of just clicking those boxes, we'd have to say product ID, comma, and we'd have to know that a comma goes there, name, comma, and product number. And then if we ran that, we'd get the same result. But again, we have to know the syntax. Over here, we're just clicking boxes and it's building the SQL for us. Let's say we didn't like the way that the product number is being displayed and we want to just call it prod num. Well, there's this column here called alias, and if we put in prod num, it will actually alias that guy. If I hit enter now, I've got name, and you see this, it's prod num. It's changed the column name to prod num. If we take the alias off, let me just do that and execute it. It goes back to its native column name. So we can use Query Designer to select our fields. We can use Query Designer to alias our field or our column headings. The other thing that is great to do with Query Designer is if we want things ordered. Let's say we want it ordered by product number. All we have to do is go over here, and in the sort field, we can say ascending and then run it, and it will take that product number and it will sort it ascending for us for the output. And then if you wanted to do multiple sorts, so this one wouldn't make much sense because we have unique product numbers, but you can do like, let's say you wanted to sort by state and then city, like on customers. What you do is you just keep saying, like, the next thing you go in here, say ascending, and it'll sort it this one first and then this one second, right? So that's how you do your order by, actually. And if you look down here in the SQL, it has put in an order by product name and then name. I'm going to get rid of that. And I want to explain just real quickly what this select 100% is. Hey, we're using a small data set here, but we could be using a database that had millions of rows. And when you're developing, this really comes into play if you're using huge data sets. Let me show you what happens. If I change this to select top 10%, so we had 504 rows, and if I execute that, we're going to get 51, right? It's going to round and it's going to give you 10% of the data. If you wanted, you can actually say, instead of 10%, you can actually say select the top 10 and then run that. And then you'll actually get 10 rows. So just remember, use the Query Designer to help you with your SQL skills. It does a great job, especially on some of the simpler type of queries when you're not getting into doing a bunch of functions or casting and converting and function this and function that. You can really get your skills up to speed quickly using this Query Designer. And I would suggest for practice that you use a Query Designer and then go over and try to write your queries out with SQL so that you start understanding the syntax of what SQL Server is looking for and needs. Now, this is going to take us right straight into a flyover of the where statement. I want you to set up your table in SQL Server the same way I am. And to do that, you basically want the fields that I have selected in your panes here. So if you look at production and the product table, we want product ID, product number, size, standard cost, and sell start date. Now I'm being intentional about the fields that we're using because a huge part of the where clause has to do with data types. And if you remember from our data type discussion, and if I right mouse click on that table and hit design, we're going to see the data types for those fields that we're looking at. So for example, product ID is an integer. So we're going to see what SQL Server does when we say we want to search for an integer, a character, something that is a date field. So as we go through these, you'll see the different ways that SQL Server handles the where clause, and it's going to actually type things in for us as we go along here. So let's start with just running this wide open. So if we have our, let's see, it's 1, 2, 3, 4, 5 different columns, and we run it, we should get the full data set, which is 504 rows. Now, the whole point of a where statement is to filter, right? So if you're used to filtering in Excel, that's exactly what we're doing here, only there's much more powerful opportunities here in SQL. The first thing that I want to do is I want to go ahead and say, okay, I'm not happy. You know, some of these product IDs are junk. I want to filter down to anything that is, it's going to have to, I want stuff, just stuff that's greater than 100 in this product ID. So if you go over to this pane here that's called a filter pane, right? So if we show the criteria pane or the filter, I call it the filter pane sometimes, and we say in the filter column on this column or this field product ID, I'm just going to say greater than 100. Now, if I put that in there and we look at the SQL, it forms a where clause for us and says where product ID is greater than 100. One of the things I want you to take note of here is that product ID was an integer or a numeric type field. And because of that, the product ID and the actual filter that's happening here does not get quotes around it. All right, you see, it actually puts the number in with no quotes around it. You'll see later when we're working with characters that you're going to get single quotes put around those. So when we run this now, it's going to limit our product ID to everything that's greater than 100. So it only eliminated a few records, but it did eliminate those, junk records that I didn't want to see. That is the way that numerics are going to work. They're going to actually just put in and you can use greater than, less than, or you can actually do greater than, equal to. You just literally put the characters in there. So if I said greater than or equal to, that filter would include the number 100 instead of being just anything greater than 100. Now let's look at product number. If we just do a quick profile of product number, we see a lot of different products. And I'm going to show you just a tiny little bit because this is just this is a flyover 10,000 foot view of the where clause, but I do want to show you a couple different things. So one of the things you can do is you can use wildcards in this filter. And a wildcard filter is you use the percent sign inside of single quotes. So if I wanted to say everything that ended with an 8, what I would do is in this filter is I would put like, so we have to use the word like, then a single quote, and then we're going to say percent. So it doesn't matter what it starts with, but then we're going to say it has to end with an 8, and I'll hit enter and run that. And then we will get a record set that's way reduced down to 83 because it went to this column, this product number column, and it looked for anything that ends with an 8 and put that in there. Now we're going to continue walking down this where path and look at size. Now the only thing we're going to do in size here is I want to show you how to deal with these guys, these nulls. What null means in SQL is that there's nothing there, which is different than a blank. And that's a whole nother discussion, but just take take my word for it, nulls and blanks are different. And in this case, what I want to do is filter out the nulls. I want to get rid of the nulls from this size field. And what you do in there, and you just say, in the filter, you say is not null. You don't say less than or equal to null. You have to use this terminology, is not null. And then that will get rid of all the nulls. We're down to 51 records. Now, let's take a look at standard cost. Standard cost, if we look at it in the design, I believe if I go down here, standard cost is defined as a money field. Well, money field is also numeric. And so when we say we want to see a certain standard cost, it's going to put it in there and it's going to not use quotes. And just to back up over here under product number, so you can see this where clause being built out, and it uses logic. It says this and this and this. It can get very complicated because you can use ands and ors, and you can use parentheses like you did back in algebra and calculus and all of that to set up logical statements that will affect the way that your data is filtered. And when we look at standard cost, we want to say, look, I only want to see things that are less than 1,000 for this filter. So all I have to do is go in here on the filter and say less than 1,000. It's going to add that filter to our where clause, and you'll notice because it's numeric, there are no quotes around it. Now, there's 51 records. Let's run it, and now we're down to 37. Let me break this kind of on purpose, just so you can see if we mess this up. If I go in here and put less than 1,000, and I put it in quotes as if it was a text, it gets mad. It says, hey, hello, this is a numeric field, not a character field. Don't put quotes on that unless you're going to use converts. And again, that's another video, more of an intermediate than a flyover. And we're just going to leave things alone. But I wanted to see and show you that it will tell you if you do things wrong. Well, let's go ahead and fix this guy and get rid of those quotes. So if I just back out of that and get rid of the quotes, it should be happy again. Run it, make sure we're good. And there's our 37 records. The last thing I want to do is take a look at this date field. So we've got start sell date. And we see over here, and if we just scroll through them a little, we have records in 2011, 2012, and 2013. Let's tell the SQL that we want to see things only after that begin in like 2012. So what we can say is we can say greater than equal to 1/1/2012. And then when we hit enter, I want to spend just a minute and show you what happened here. If you look at this in the SQL, it says start sell date greater than or equal to, and look at all this crazy stuff it added to it. It basically converted our string to a date so that the date could be used to compare to the date field type. This is one of the beautiful things about using the SQL Server Query Designer is in many cases, it will take care of these converts for you and make your life so much easier. And now if I run this and take a look at it, now I've got the 2012 records, the 2013 records, and there's only 21 records left. So we have this big, I'm going to turn off this top pane so we can see a little bit better. But we have this great big huge query that has 1, 2, 3, 4, 5 different criteria, and it's limited our set from over 500 records down to 21. Now this is the exact set we're looking for, and all of this was built by just putting information into the filter. And just a reminder, I hit Control A there to grab everything and then copy and put it over into here, which is a new query. Now I can run the exact same thing with the code. And again, it won't hurt you to get in here and type this code out as well as using the query designer so that you learn and understand. And sometimes just coming in here and even formatting this guy, like saying where this, and then we can say and this, and just go through them so you can look at the way that SQL Server put all this together so that you can understand it better. It's a little bit more readable here in this query pane. That is it for the where clause. We're going to go ahead and move to our next flyover. Now, I know you're excited about this next flyover where we're going to take a look at joins. And look, there's no way in this flyover we can get you all the information that you ever needed to know about joins. But I want to leave you with, some good examples of why you would want to do a join and how to do them in SQL. So what we're going to do is I'm going to clean up this pane here, and we're going to we're going to break out the good old query designer. So new view. And then I want us to grab the customer table. So let's put that guy in there and let's just put in the customer ID, person ID, and let's run that. If we're trying to figure out what our customer is, right? And you can see like these numbers. We've got a customer ID, we've got a person ID, but see, like person 9814 doesn't mean much to me. Now, what you're looking at is what we call normalized data. And so to keep things optimized again from a size and space standpoint, data architects will utilize IDs to point to something that's stored once instead of restoring the same thing over and over again. Like my name, Billy Thomas. So instead of having to store Billy Thomas over and over and over and over again, they'll say Billy Thomas is person ID 1000. So they just store 1000 instead of Billy Thomas, and then they just point to a table that has the correlation between the ID and the name. So that's what we're going to do, and that's why you want to use joins. And you're going to use joins all the time if you get to become a data consultant or a data analyst, or if you're just trying to query somebody's data to get information. It will most likely be normalized, and you'll need to pull things together in chunks from different tables. So we've got this person ID. What are we going to do with it? Well, if we look through this data model, we should find something in here around that ID. So here we go, person.person. Let's take a look. Let's drag this table right into our designer and look at that. Now, you won't always get this line drawn for you because we're using a prefabricated Adventureworks database here. Microsoft has made those connections for us, but if they hadn't, all we would have to do is draw the lines to that. Now, if we run this, this is an inner join. And what an inner join does is it says, I'm only going to show you records from the two tables that match. So I have to have a match over here and a match over there. Take a look at this record set here. It's 19820. When I run this after the join, it's going to have a different record count because it eliminated records that did not have a match. Let me change this from an inner join to an outer join. And right here, I can just say select everything from customer. And you see you get this kind of like boxy end here and a pointy end here. So these are like the good guys. These are the bad guys. I want everything in here, even if it doesn't have a match. And that's why you would do an outer join. Now, if I run that, our 19119 goes back to 19820, and you can see what SQL does anytime it doesn't find a match. In other words, it's not finding a customer ID over here in the business entity ID to match, then it just gives a null, right? And then a quick way to say, well, how many customers do I have that don't have a match over in person? I can just go over to that person and filter for it and say is null. And then this would be my list of customer IDs that don't have a match over in person. There's about 700 of them. And of the almost 20,000. So, that's not bad, but that would make a great data quality report. We should have a match there for all those records, ideally. Now, inner join, outer join, right? The biggest thing to remember with joins is just simply that an inner join will limit the number of records or will limit the new data set to the matches, okay, the records that match on the IDs. The outer join will say, and technically if you say like a left outer join, so the table that's on the left here and or that's mentioned first in the join. So if I look in the SQL here, it'll say from customer sales left outer join, meaning keep all the records from, I want to see all the records in this first table regardless of whether I get a match on the key that I tell it to match on. Now, let's take a look at a little bit different example. Let's say we wanted to see customer. Oh, wait, before we go there, one of the things I want to show you is let's go back to an inner join because I want to show you why this is important. Oh, I clicked the wrong one. When I have these two numbers, I still don't have the information that I need. So I had, person and customer being displayed here, customer ID and person ID, but I still don't know who this is. If I look in this table, there's some information that might be helpful. If I add in the first, middle, and last name, now it says, okay, for this customer is this person, that person is Catherine R. Abel. Now I've got some information that's way more useful for reporting or for business purposes. That is the primary reason to do a join, is to go out and to gather more information. So you've got a data set, you need more information to complete a data set. So you go to another table, join them together, and now you put all that together and you get a more complete data set for reporting or whatever you're doing for the business or your fun time. And let's take a look at another example of an outer join. Let's say we wanted to see all the customers here that don't have any sales. All right, so we can leave this in there just for fun. So these are customer and with the person attached, that's fine. But let's see what of these 19,119 customers, I wonder how many of them don't have any sales. Well, let's find a sales table. And right here is a sales order header. And if we look inside of the sales order header at the columns, I'll bet you we find something about a customer ID. So right here is a customer ID. So we can use this table and link them by customer ID, and we'll see if there's any records in the customer table that don't have records in the sales order header table. So what we're going to do is drop this guy over into the pane. And look, again, it's drawn the line. Now this time it's drawn it from customer ID, which is the key in this table, to customer ID in this table, which technically the terminology for this guy would be the foreign key, right? It's kind of a foreigner lives in another table, but it's what it allows us to link this together. Now, if we just run this data, which I like to do along the way as I'm building a query, you'll see we go way over our record count. Why would that be? Well, we have customers out there that have ordered more than one time. And when we do a join, it takes the information and joins it together, and it displays all the rows where they're equal. So we've got 31,000 rows now where this information is equal. And if you look at this, it's actually, you see the same customer ID in triplicate here. Like, look at this guy, 11,000 is mentioned 3 times. There's 3 rows of data for this John Yang. Why is that? Well, if I look at the sales order ID, I'll bet you it's different for those 3 records because it is multiple sales orders, right? So this guy has, this customer ID 11,000, John Yang has customer or sales order ID 43,793, and these other 2 as well. So they have 3 sales orders for that one person. Now, if we wanted to actually see what we were going for in the beginning, which is, okay, let's see which customers don't have anything in here? Or in other words, what customers don't have any sales? Well, the way we have to do that, that word don't is a key for us to think, ooh, I'm going to have to do an outer join. If it says, if you hear somebody says, well, they have or has, a match, that's an inner join. So what I'm going to do is I'm going to change this and I'm going to say, I want to see all the customers regardless if they have sales. So we're going to have this guy with the square box pointing to what I call the good guys, and then the arrow pointing to the bad guys. Now, what we need to do is we need to drop a field over here so that we can see when we have matches and don't have matches. And let's do that. All right, so for this customer and this sales order, we're finding matches. Now, let me just scroll down through here and let's see if we see anything over here that might be missing a match. Right now, I'm not seeing any. Let's use an expression, say, where that guy is null. Okay, so right now I'm not seeing any customers that have a person attached to them that don't have a sales order. Now, what if we remove this person and run it? Now we're finding some customers, and the interesting thing about this is, once they have a sales order, they probably make them put their name in. And so these are customer IDs without any sales, and there's a 700 of them, and we were able to find that with an outer join. So inner join and outer join are very helpful and useful, and you can do them very easily using Query Designer. If you have to do it with just typing out the query, it gets a little bit more complicated. Let me just show you real quickly how we do this manually. You have to go to New Query, and now it becomes a little bit cumbersome because we've got to know everything and fully qualify it to get it to work in here. So let's start with our first table. We're going to say select star from sales.customer. Let's get that rolling. Okay, we've got that information. Now we want to know, well, what fields do you want? Well, I want customer, and we're going to have to qualify it. Sales.customer. Customer ID, and we want person ID. And again, we've got to fully qualify it. Sales.customer ID. Okay, so now let's run that. Now I've got my, it's supposed to be person ID. Great job. Same field twice. Person ID. Run that. Okay, so we've got our sales ID, our customer ID, and our person ID. Now we want to tie that over to sales order header. So what we have to do is we have to start out by saying inner join, and then what's the table name? So fully qualify it. Sales order header dot. Actually, I need to do this. Sales order header. That's the table name. And then you have to say on. Well, what are we doing it on? We're going to do it on sales.customer ID equal to sales order header customer ID. So we're saying, take a look at the customer table, take a look at the sales order table. I want to use the customer ID field to join them together. And now if I run this, it runs, and you can't see it because I am in your way, but trust me when I tell you there it is, 31,465 rows. Now, that's all good, fine, and dandy, but you can see it didn't even add anything new into our results. To do that, we've got to come back up here and say, well, what do you want to see? Well, now I even got to go over here and like, all right, what fields do I have? Well, now that I've joined them, I have access to any of this. So if I wanted to see, for example, the total due by for this customer, and I can add in, let's see, let's put in the sales order ID and the customer due. So sales order ID, sales order ID, and total due. Now, as long as the field that we're looking at isn't in both tables, you don't have to fully qualify it. In other words, you don't have to put the table name in front of it. It's a good practice to do, but I want to show you that this is going to let us get away with not putting the table name because it knows exactly there's only one place to get it from, and it gets it from that table. So now you can see we've joined it together. We have access to customer ID, person ID, sales order ID, total due, and now we can do our other SQL things if we want to. So if we want it ordered by, for example, let's do person ID and run that. Well, what happened? Well, I said ordered. It's order by. How about that? There we go. So now this customer, 29484, has all these sales orders, and there's the total due for per sales order. There, I got it out. So there you go. Inner joins, outer joins. They're very powerful. They can be very complex, and trust me, it will take you a little while to really fully wrap your head around the different joins. And now we're ready for our last flyover, which is going to be to take a look at functions in SQL Server. What is a function? Well, really, a function is just a piece of code that comes pre-delivered, and actually not just pre-delivered. You can create your own functions, but for this tutorial, we're going to talk about pre-delivered functions and just a couple of them. But half the battle is you knowing that they're out there. And I want to show you a couple of them that are used all the time, but also refer you to the SQL Server documentation and other YouTube videos that talk about SQL Server functions, because the more you can get an understanding of this, boy, it can sure make your life a lot easier as you're trying to fulfill business requirements for writing SQL reports or data quality reports. What I want you to do to get set up is really open up Query Designer and pull that product table into the pane. And let's pull in the product ID, the name, the product number, and the cell start date. And you should get a data set that looks like what I have right here. Well, one of the things that happens often in business requirements is they'll ask you, say, hey, for those products that are out there in the database, I want to know what sold in the last year. And sometimes that can mean the calendar year, right? So you would say, well, greater than or equal to whatever calendar year you're in. But a lot of times it is, they want to know the current year, or there's a rolling year, and it's based off of today's date. Well, SQL Server comes predefined with a function called getDate, and that lets you know what today's date is, and it's a variable, so that whenever the query is run, it goes out and gets today's date and then does whatever with it after that. So let me just show you real quick. So if I tell SQL Server to select getDate and run that, I hit the wrong F key. It goes out and says, all right, well, the day of this video was 7/7/23, and it gets not only the date but the time. All right, so get date is a date time function that returns date time. If I put it into the query designer and I say get date as a field, it will show the date that that query is run and time. There we go. And then we can alias and say today's date. Run that. Okay. Now here's where it gets interesting. We know that it gets today's date, but what we want is today's date minus 365. Okay. So what does that mean, right? So 365 days in a year minus leap years. So let's not get into that right this second. But for the purpose of this video, let's say it's 365 days in a year, and we want to see anything that's been sold in the last year. Well, we've got this field on here, this cell start date, and in that cell start date, you can see there's different dates and different years. Well, let's see if anything's been sold this year. Well, in cell start date, we can go over to the filter and say, I want to see anything that's greater than or equal to get date. So today's date back up 365 days. So minus 365 days. Let's run that and see what we get. So we went from 504 records down to 6. And if we look at the sell date, we've got January 12th, February 16th, February 17th, May 1st, June 15th, and July 3rd for sell dates that have been in the last year. Very powerful function. You use it all the time. And there's a lot of other date functions. So if I go over here just to demonstrate them really quick, I can say, show me what year we're in for today's date, right? We're in 2023. And let me just do some, what if I want to see the month of, right? It'll pull back July. What if I want to see the date, the day, I'm sorry. I got to get my keystrokes going on right here. The day, right? So you can kind of segregate out the month, the day, the year, right? Now it happens to be 7/7, so they're showing the same, but it's pulling out the date, the day of the get date, the month of the get date, and the year of the get date. There's so many more date functions. There's date diff and other things that can tell you the difference between two dates in years, days, or months, so on and so forth. And then there's also these things that you use in Excel all the time, like a length statement. So let's say I wanted to know the length of product number. All I have to do is go over here to the field and say length, and then put the field name in. So product, can't type product number, and let's call that length prod num, and then run it. And over here, we should see the length of the product number. Sometimes it's 7, sometimes it's 10. And then that can even be used to be something that we query on. So we might want to only see product numbers that have a length of 10. And boom, there's 3 of them that have been sold this year with a length of 10. Again, I don't want to, try to give you the false hope that we're going to go through all the functions in this video. I certainly will be making more videos in the future around functions and different functions that you may want to go ahead and subscribe to my YouTube channel so that you don't miss any of those. But for now, this has been a quick overview of functions, and now it's time to take this thing in for a landing. And that concludes our tutorial of SQL Server. I sure hope this video was helpful to you. If it was, please like, share, and subscribe to my YouTube channel, and have yourself a great day.